It's almost the first minute of the year of OChem. 15 so far, I think. We have 12 times 3 plus 6. There should be, yeah, I guess I'm doing that. Should have about 42 total, but we'll see how many we get. Maybe the first one. I didn't do a good job telling everybody today's lecture time in my email, I don't think. All right, so before I start on the intro, do you guys have any questions? Or guys and gal, everybody have any questions? Folks have any questions?
For the lab, do we need a lab notebook, like an official one?
You know, I don't, nothing official, no. Just like one of these is fine. Any kind of bound paper. And in a lot of the labs, especially this semester, it's not so much about having a formal lab write-up kind of thing. It's more about, I'm teaching you techniques to use in lab this semester. And I guess writing in a notebook is a technique, but I don't spend a lot of time on that. So anything with bound paper, usually people get the other ones. Those really inexpensive, like I'm not seeing one.
So just like a 70-page notebook will work?
Yeah, that would work. Yeah, you definitely don't need those carbon copy things.
Yeah.
I'm trying to find, I thought I'd have some of those, you know, the ones that are like bound with that random pattern on it. And it's like usually like only a couple dollars, pretty cheap.
No, but I have a spare 70-page one, so.
Okay. Yeah, you're good. You'll see like the first part of the lab we're going to do, we're learning how to use the NMR and the IR. So you don't even really need a notebook. You're just going to go through this packet I made up for you. And that'll take a while. That'll be like the first month. All right, we got 15. That's pretty good. Any other questions before I get going? Okay. Well, I'll share my screen. And please, if you can, do me a favor. If I'm doing something dumb, will you let me know? Like if I'm not sharing my screen and I'm talking about something you can't see, etc. Okay, so I guess all of you here got in through Canvas, so that's good. So you're into Canvas, you saw the Comp for Zoom link. Was there any issues with that for anybody? Okay, sorry, I should reread my email now. Okay, so, okay, then I'll start with the intro here. So I make these Google slide animations up to start each lecture. And I wish I could bring my puppy to class. She's not a puppy anymore, but she kind of looks like a puppy, you'll see. So I'll start each lecture with the Google slide animation, just to, and it's a good thing to keep track of everything that's going on, because throughout the semester I'll say, okay, remember there's going to be a quiz, there's going to be this assignment's almost due, and it'll just keep you informed, because I try to make the class, I want the class to be somewhere where you're challenged to learn a lot of OChem deeply, but you're not challenged to like figure out where things are and it's confusing. So I try to keep it real straightforward. So let's start with that. Get rid of this guy for a second. Hide. Loading meeting controls. Good. Okay, so welcome to OChem. It's Monday, August 23rd, 2021. And we'll have an intro where I just, kind of intro on some of the way we do things. And then we'll start on chapter 1, organic molecular structure. So the phases of OChem. So this is our dog Sky when she was a puppy. So wow, I'm in OChem world, just starting out. And then the phases of OChem where you're like, wait, I need to know all this for the exam. So you're going to go through a period where you're like adjusting to the material, learning it, getting a feel for it. And then, oh winter break, what took so long. You can relax over winter break. And this class is, as I'll say in a few further slides, I think it was it was probably my favorite class in college, and that's why I became an chemist. And but also I felt like it took me from being like a good student to like a much better student, where I could not study as much and still get a great grade, or even understand it better without as much time, because I just get smarter about how I studied and learned. So I want to get you there too. So these outlines that I'm clicking through now, they'll be giving you instructions, reminders of what to be done in the class, and advice, like I said earlier. And I'll link these outlines on our Canvas site in two ways. I'll have this animated Google slide, you'll have a link to it. So you can just click through it like I am now. And it'll also be a part of the video, like I'm videoing it now. It's good to watch the video of the lecture first, because I'm talking more about the animation than just the clicking. But after you've watched the lecture, then like next week, if you're like, what did he say about that? It's nice to be able to go to the animation, because it's much quicker to click through than to watch a whole lecture. Yeah. And then I'll present much of my material during lecture on Google Jamboards. I found these, or I started using these, I think it was last semester. During this pandemic, I kept coming up with new things, like finding new things. I'm like, oh, that's much better. So I think it was mainly last spring in 12B, I started using the Jamboards, and oh, they're so good. This is one of the best things about the pandemic in terms of my teaching, because it's easy to use different colors. Like on the whiteboard, I have different colored whiteboard markers, but you can do that here as well. And then you can paste like a picture, a photo from the internet or something, just clip and paste it on there. And you can, then after the lecture's over, that Jamboard will be linked, and it'll be in a list of like, okay, here's Monday's lecture, Wednesday's lecture first week, and then Monday, Wednesday, the next second week. And you'll be able to go back to those Jamboards. And it's nice, because if you've watched the whole lecture, it's, and you want to have a question about that lecture, you will have that video available to look at, but it's even quicker to go through the Jamboard. So it's nice. And in the past, when I wrote everything on the whiteboard, it would just be erased, it was gone. But now you have it for the whole year, which is nice. One good thing about the pandemic. And I'll also do office hours with the Jamboards, which is even better, because I got good at this last year, where I would have normally about, I don't know, like 6 to 12 students would come to office hour. And normally, if we were in my office right here, I have one whiteboard, and I'd write up a problem, and someone would work on it, and others would watch. But now, because the Jamboards, I could set up this Jamboards that have like not just one whiteboard, but you can have up to 20 per Jamboard. So I can say, okay, Morgan, you're on Jamboard 1, Demonpreet, you're on 2, and then you just go down the line, and then they could everybody's working it out. And there's so much more to you actually working and writing something out than watching a classmate or me do it. It's so different. So if you're working on your own, then I can click through all these Jamboards. Oh, wait, you forgot the charge there. Or, oh, you got this mixed up. And it really helps. And we have a past peer as well. We're lucky. So I just use the name Morgan. So Morgan, and I always want to say Fenning, but it's Fennig, is our past peer. And he's a superstar from last year's class. So we're really lucky to have him. Normally, most of our students after 12B, they transfer usually to Davis, UC Davis. And those who are still finishing up a couple classes here, we're lucky enough to have them. And Morgan's one of those. And Morgan's, I believe, last I talked to Morgan over email, he's going to do Monday, Wednesday past peer sessions from 9 to noon. So that's awesome. You'll have a lot of time to work on stuff. Is Morgan here today? Not sure if he was able to make it today. Don't know if I see him on the list. No, I don't see Morgan. He's probably trying to add classes and this and that. So yeah, so we have Morgan in our class. And yes.
Is there any other times Morgan would be available, or any other OChem tutors, like in a tutoring center?
I think no, 100%. I'll have to ask. Maybe Morgan actually tutors in the tutor center as well. I'm not sure. And I asked last week if we had any OChem tutors this semester in the tutor center, and she's like, oh, I'm not sure yet, but she's going to get us a list of the tutors within like this week or next week. So hopefully you won't need a tutor right away this week, but we'll have a list. And we might be really lucky, because normally a lot of semesters there's no OChem tutors because they've all transferred on. But now for this semester, at least, maybe next, the tutors that were OChem tutors, say last year, they can still be a tutor this year if they're at Davis, because you can do it via Zoom. So that's kind of
Okay.
cool. So we might be lucky. But besides I think the best tutor on campus by far is actually me. Not because I'm that great, but because I write the exams and I know exactly what I want you to know. So try to come to my office hours if you have the time.
And
if you
when are
can't,
those office hours again?
oh yeah, I haven't gotten to it yet, but my
Okay.
office hours are Tuesday, Thursday.
Okay.
Tuesday, Thursday, 9 to 10.
Okay.
Yeah, Tuesday, Thursdays, 9 to 10. So you'll have Monday, Wednesday, 9 to noon with Morgan, and Tuesday, Thursdays, 9 to 10 with me. And then also I help you a lot in lab too. So I kind of treat all the dead time in lab. I don't, it's not really dead, but time where you're like, you got to heat up a reaction for an hour. Then I have you work on stuff and help you. So that's like an office hour too. And then this will hopefully and most likely be your favorite class in college. It's challenging and you'll work hard, but when you're done, you'll not only learn a lot of chemistry, but you'll be a better learner. I say this because that's what happened with me. And I feel like that's what I hear from my students a lot. And I see it too, like by like the middle of this semester, or the middle of next semester, it seems like my class becomes totally different. Like they're different people. They're so much better at learning and they've come such a long way. It's nice. So after I completed OChem, yeah, my study skills got a lot better. And when I took biochem and physical chem, I didn't spend as much time actually studying, but I still got A's, and it was nice. So some comments from my my former students. So I'm kind of being manipulative in my bragging here, and I'm not even meaning it to brag, but what I mean by manipulative is I kind of believe in this theory that like if you go to a big name school like a Harvard or Berkeley or Stanford or Davis, and you're surrounded by other students who are super hardworking, then it sort of becomes an environment where like, okay, like really understanding and learning is just normal here. So you'll work harder. Where like when I was at Davis, I remember they had like a study room that was open 24 hours, and you can go in there at 3 a.m. and there would be 20 people there. So I'm not saying it's good to stay up all night, but but if you have 20 people around you working hard, it seems easier to work hard. It's sort of like if I go on a jog by myself, like for 1 mile, I'm just like dreading it. But if I sign up for one of those 5Ks and I'm in a crowd of people, it's so much easier, just the thing. So I want to, and also if you feel like, oh, this class is going to be good, it might, fake it till you make it. It might be. So here we go. So I always get emails from students that have moved on. So here's one who went to pharmacy school, said they're happy the class helped them out. I'll go through these quickly. You can read them if you want, but you don't have to. Here's a really good one. Ben, he got into Johns Hopkins Medical School, full tuition scholarship for medical school. It's awesome, huh? And then this one, yeah, this was a student who transferred to Berkeley, did real well. She's done now. I think she's working. Or is this the Berkeley one? Yeah, I don't know. Yeah, you could check these out. I'm just trying to sell that if you put your effort into this class, it can really change your life. It can make you go far. And I also want you to know each other as well. I'm sure a lot of you already know each other. Well, probably less than ever now. Which stinks because of the online teaching last year. But normally my OChem students, they come in pretty familiar with each other because they might have had math, biology, physics, chemistry, or whatever together. But then in my class, they become even more tight. And I try to encourage that because I know it's going to help you. It's really help you to have that community. So some of my former students like to on Facebook, you'll see the pictures of the kids. They got married and stuff. It's nice. Yeah, especially when you're struggling in a course or just in school in general, if you have someone else around you, it helps a lot. Like I remember when I would be in a class, I'm like, I'm totally clueless. And then I would meet a friend in the class and I talk to them and I'd realize, oh wait, they're totally clueless too. Okay, good. I'm not alone. Because a lot of times in classes, the students can all be really quiet and it looks like they're all getting it because they're all just quiet. And then you hear one of them ask a question. You're like, whoa, wait, they're behind. They don't understand it near as much as I do. And I'm totally lost. So this is good. So it's good to know, where you're at, but you guys won't. I don't present the class in a way where you'll feel completely lost. You'll probably just feel like I need to get the work done. Yeah. I try to have a friendly demeanor with my class. I get to know you well. And for whatever reason, I hate when I find people cheating. I just don't like it. So please don't cheat. I know online now, that's like so easy to cheat online. And but now this semester, I'm like a lot calmer about it because I'm going to be having you take exams in lab in person and quizzes and things. And it'll just help you because I know like if you start off with every quiz you take, you're just looking at the answer. Then you get to the exam, and it's my exams, I write them up new every time. So it's kind of hard to cheat on the exam. I'd noticed that sometimes like a student would ace all their quizzes last year and then they take the first exam and just bomb it because they weren't able to, in the time window, find the answers online. I was like, but that's not such a big deal now, which is good because I really just want you to learn. So don't cheat. And enough about that. And then here's our syllabus, and it's linked in Canvas as well. Let me check. The syllabus doesn't have all that much in it. I used to have a 70-page syllabus. I put everything into it. Now it's just like kind of a shorter main things here. So here's what I was talking about before. My name is Mark Springsteel. That's our dog Sky when she was kind of a teenage puppy. She's an Australian Shepherd, kind of a medium Australian Shepherd. And quickly a little bit about me. My family's from New York. I was born in the Bronx, but I was like 3 months old. We moved to California because my Uncle Frank had work for my dad out here as carpentry. Uncle Frank worked with John Wayne's son. I don't know if you heard of John Wayne, the actor. Uncle Frank and John Wayne were friends because my Uncle Frank worked on his house, and then they would like buy apartment buildings and flip them in the 70s. So that got us out to California. I grew up in Orange County, actually, Tustin, which is in between Irvine and Santa Ana. And then I went from Tustin High School, I went to Cal State Fullerton. And then I did actually a semester, at Orange Coast College. That's a community college down there, like us here. And then I went to UC Davis for grad school, got my PhD in organic chemistry. I was looking for drugs to treat cystic fibrosis. I made these flavonoids and other molecules for hopefully treatment for cystic fibrosis to help those patients. And while I was doing that, my research group, I was doing the cystic fibrosis. I was one of the only ones, but there was another 3 or 4 lab mates that were working on these cationic lipids. They're like fats that are kind of the opposite charge of normal fats, artificial fats. And they're using it for gene delivery, trying to hopefully have gene delivery occur where you can add some DNA in this fat ball and give it to someone and it corrects their, say, cystic fibrosis even because of the genetic mutation. But that was something that like, it seemed so promising and we were working so hard at people around the world and it wasn't quite getting over the hump. But then the pandemic just came and now our Pfizer vaccines and the Moderna, they are using cationic lipids like the one our lab was developing in the early 90s. And so they finally got it over the hump. So now I think it's going to be, in my opinion, it's going to be one of the world's largest medical achievements because they're already working now on using this delivery system, the cationic lipids that hold like the mRNA for the coronavirus. But they're also working on it now. They're in clinical trials with HIV and with malaria, and they're working on cancer therapy with it. So some people are like thinking, some microbiologists are like, oh, we might be able to cure all human disease in like the next 50 to 100 years because of this delivery system. So it's pretty amazing. We'll see how it goes. Okay, so here's my email. You can email me anytime. This is my phone number in my office. I got a new phone and I don't know how to work it, but my best way to get a hold of me is email, but you could try the phone and I'll eventually figure it out. And then so lectures are Monday, Wednesday, 11 to about 1, I'm saying. Yeah, we'll see. And then lab on campus in person. There's the Monday, Wednesday lab section. Then there's an early Tuesday, Thursday, and a later Tuesday, Thursday. Office hours, like I said, Tuesday, Thursday, 9 to 10. No textbook. I have a lot of material for you to go through without, you don't need a textbook, but if you have a textbook, feel free. I think now with the internet, you don't really need a textbook because there's online free textbooks. And I feel like for organic chemistry, pretty much all the organic chemistry textbooks, they're pretty much the same in my opinion. So I would just, if you want a textbook, you can actually borrow a textbook from me if you want. I got a bunch of stragglers laying around if you like that. But another thing you can do is if like whatever topic we're studying, if we're studying like bond line structures, you just Google it and there's probably a video that's better than the textbook. I don't know, whatever you like to do though. And I'll let you read the rest of this. Prerequisites, you have to finish the year of general chem and have a C or better grade in the last one. And then, yeah, we got our course learning outcomes, lecture topics. This outcomes here, these list for, I used to use a textbook and I have these outcomes based on chapters, but we don't use a textbook now, but it's still nice to have them in chapters. So these outcomes will list for each chapter, whatever we go through. It's the material is right there where, like, if I say exam 1 is going to be over chapter 1, 2, and 3, you can go through that list and all those topics, that's what you're responsible for. And if you know how to do all those well, you should do well in the exam. And the laboratory schedule is here. I don't know, I'm going to call it laboratory schedule. I have both lecture and lab one. I was kind of thinking of making 2 schedules, but changed my mind. All right, and then I'll look at that shortly. Let me just finish the syllabus. And if you have any disabilities or hearing, and it keeps getting worse. I'm getting older now. My son's always messing with me. Like if people talk to me and I'm looking, if they're looking away from me, they talk to me, I'm like, shoot, I can't hear them. Like, but we work through it, right? And my eyesight, I can't see anything good up close now, but when I put the glasses on, I'm good. But far away, I'm still really good. I don't know what happened. Just getting old. Okay, so that's the syllabus. Let me come back here to this guy. Any questions so far? Interrupt me if you have any questions, but feel free. Yeah, so here's the, like I was saying, the chapter outcomes. So here's a link to these. I'll show you, get a peek at them. So you just go through chapter 1, organic molecular structure. First off, you gotta need to know how to draw bond line structures. We'll be doing those today. And I've been creating these things like these animations. And I think they're really good. I noticed that whichever topic I've gotten a chance to make an animation for, if the students go through it, they're really good at that. So I'll check this chat really quick. And so I've embedded them now in the outcomes. So it's kind of nice to have it all right here. And I've made a lot of these. I've done a couple things with them. I used to just present them to the students and say, this is a really good tool. And the ones who did it would get a lot out of it. But then now I've said, no, let me just make everybody do it. So I've put these, this is kind of my plan at this point. I've put these into homework, like it's like, oh, homework number 2, go through this. And or usually I'll make like a quiz out of this, a real obvious quiz. So let me show you this bond line structure thing. So this is the first topic we'll talk about today. So it starts off, I use most of it's in Google Slide now, I think. I started with PowerPoint, but it's hard for me to share PowerPoint. And then when I do PowerPoint online, I can't really animate it afterwards. So I've gone to these Google Slides, and I think they're more like easily shared, easily viewed on your phone or on your tablet. So you'll see usually always like a big click to animate to start, because it works much better there. And I try to make a theme to them, not all of them, but most of them, make it interesting and fun. Black, there we go, yeah. So, and so once you click to animate up here, it starts off, this one, I think I even put music in and stuff. So I'm trying to present this bond line structure as like the secret language of OChem. We've got like the Illuminati and does anybody know what this one is? So this is the Illuminati. Does anybody know what this secret society is? I think. No one? Harry Potter? The Deathly Howls. And then Sierra College. Oh, maybe we did have an answer. No Harry Potter fans. And then the Freemasons. Skull and Bones. All right. So I'm trying to make it fun and interesting. And this is like, I made this up last year before the vaccines were out for COVID. And this was a big breakthrough at the beginning of COVID. This common steroid was used to treat COVID patients and really help. So this helped with the mortality rates in hospitals when the first patients of COVID were showing up and they're trying to figure out the best way to treat it. And it's actually something that's been around for a while, so that was nice. It was inexpensive. So it helps treat skin diseases, asthma, and COVID. And so here's where you click through, and it's just little jokes and things in here, right? As you're clicking through it, try to have a paper and pencil out or a tablet or something and work through the examples before you click, and you'll really get a lot of it. And so I'm not going to go through the whole thing right now. I just wanted to give you an idea of it. So this particular one, remember in the beginning I said I'll either like put them in the homework, or I'll have like a quiz. So this one I'm doing it as a quiz. I'll show you. So here, towards the end, I've got, oh yeah, here it is. So practice quiz time. So here's a quiz that I'm giving you the quiz here, and then the animated answer key. So if I present from this point, you'll see, whoop, it gives you the answers that I want you to do. And not only is this the answer key that you can practice, this is the exact same quiz you're going to get in lab. So it'll be this exact same structure you're going to figure out. Nothing's changed. So it's like I'm giving you a quiz that before you take the quiz at home, you have the exact quiz you're going to take and the answer key. So you can practice it. So when you come in, it should be easy to ace. And then with these quizzes that I've done in the past, I usually have like a 95% average, because it'll be the person who maybe just, oh, I had a physics test and I didn't have time to look at it. That's the person who doesn't do well. But so I feel like giving what I think of these as kind of like obvious quizzes. And I feel like they really work. At first I was like, oh, you shouldn't just give students the quiz and the answer key. But for these key concepts, these are just like skills. It's like if you were learning a sport, like if you're a basketball player, you practice free throws. It's kind of like that, just getting the skill. And then I came up with another idea this summer as I was going through and updating these. I'm making it like you're going to binge learn. So after you say, if I present this, you go through the quiz, you practice it yourself. You're like, okay. Then you go to the last slide and it's all up next, bond line structures in 3D. So you can binge learn on. You just get clicked to the next one. And then here's the next one, bond line structures in 3D. And here we got the magic eye. Has anyone seen these? Now this is even older than Harry Potter, where you stare at these and they 3D image pops out. Let's see if I can get it. Yeah, I see it. There's a tree and a moon and a leaf falling from the tree like a fall. Yeah, so these are pretty cool, the magic eye stuff, stereograms. So, all right. And at the end of this one, I have a quiz as well. Yeah, you'll be filling in these ones. Cool. So yeah, that's the, and right now I know I'm throwing a lot at you. Don't feel like you have to memorize every single thing I'm saying, because as we go through the semester, I'll be reiterating, okay, now this is what we're doing next. This is just, an overview. All right, so we got the outcomes. And then I think this was May, yeah, last semester. Yeah, I thought like, I was figuring out how to use Canvas, but I felt like it was just confusing to me. Like I don't really understand the logic a lot of times in Canvas. And I feel like when I took like my teacher training class that was in Canvas, I was constantly spending time just figuring out what to do, where to find it. I was just like, it just seemed a little complex for me. So I like to keep things more just simple, like, okay, week 1, here's what you do, week 2, week 3. So I came up with the idea, just have like a step-by-step thing where I'm like saying, you just do this, then this, then this, and you're gonna get through OChem and learn a lot. So here is my OChem step-by-step Google Sheet. So I was always Microsoft for the longest time with PowerPoint and Word and all that, but then I've gone to Google stuff because it's easier for me to share and to make changes than it was for me in Microsoft. So that's why you'll see like Google Sheets is like Excel for Microsoft. So this thing you'll be using a lot this semester. It'll just be like kind of a place to come and get everything you need. You'll see the schedule link, the outcomes, the due dates. When we have exam keys and things, I'll put them there. The animations I was telling you about, those Google slide animations. Mechanism database. I'll talk more about this stuff later. But like, so week one, here we are, week one. It starts today, 8/23. And we have the lecture outline. So the lecture outline that I'm currently going through, it's linked right there. It's ready to go. And then, oh, actually, I want to put this here. Then the lecture, the video, once I'm done, I'm recording a video right now. When I'm done recording this video, I'll put it into, I'll upload it to YouTube. So you can have a link to it there. And then the Jamboard that I'm going to use today, which is, you'll see shortly, there's a link to it there. And then tomorrow's office hour Jamboard will be here, and you'll just kind of go down the line. And then I also have for each week, this is like week one, right? I'll have the assignments here. So in lab, we're going to start off, like I mentioned earlier, how to use the IR and the NMR. You'll learn what those letters mean. High risk waiver, bond structure. So this high risk waiver, you can, that's just easy, just fill it out. You could do that right away. And then the bond line quiz, remember I showed you that? I said the quizzes in class is going to be exactly, in lab you'll take, exactly like the one from the animation. It's going to be, you're going to do that this Wednesday, Thursday in lab. And then we've got homework A, chapter 1 on there. So assignments are here. So this organic chem step-by-step will be basically your go-to place where you just feel, well, each week, what do I do? Here's what I do. Do this, then that, then this kind of thing. Okay, getting there. And then here's our tentative schedule, because hopefully we continue to be hybrid and we can come into lab, come into lecture. And also just because, I don't know, I'm always changing things around. And so sometimes I find, oh, you know what? I need to give you more time to finish that experiment or this or that. Or, you know, so I'll let you know as we go, as changes make. And I'm not going to make changes like last minute, like, okay, now your thing's due tomorrow, you know, I'll give you time and things like that. So we do have a lot of quizzes I decided to start off this semester, because these like obvious quizzes, the bond line structure quizzes. So in lab.
What? I'm sorry, but what are the formats for the quizzes and for the homework? Is it through like a WebAssign, or is it, or fill in, or what?
The quiz, I'll go grab the quiz real quick. I printed it up already. So for the quizzes, I already let me see myself. Yeah, so I already printed up the quiz for the online structures. So if you, does this look familiar when I was clicking through it and that Google slide animation?
Yeah, okay, so those will be in lab.
This will be in lab, and
Okay.
you just write it out with pen and paper. So that's for quizzes and exams, will be on paper in lab. And then the homework, though, the homework is up to you. You can do the homework online, like you probably had to do last year for all online stuff, or you could do it on paper and turn the paper copy into me in lab. So I'll leave it up to you. Yeah, I'll show you the assignment. So if you come to the assignments here in Canvas, you start off things to do in the laboratory. You got the high risk waiver. We got these workshops we're going to start with. And so here's homework A. So you click on that and it says you can turn it in as a PDF you upload here, or you get paper copy in lab. And here's the homework. It just has some questions, and you don't have to print up this homework. The homeworks and things, it can be pretty long, like some are like 70 pages, not the homeworks, but the lab workshops and things. So I don't think you want to print those. And so for like this homework, for example, you don't have to print this, but if you wanted to do it by handwriting it out, you can just say, you know, on your piece of paper, blank piece of paper, number 1, and give the answer for this 1A, put the answer 1B, the answer, you know. And Or you could do that on some people who have they really like their tablets. You could do it on a tablet and then save it as a PDF and then upload the PDF. I'm leaving it up to you. Does that help?
Thank you. Yeah.
Yeah, you're welcome. All right, so boom. And then here's a Google slide animations. Fun, efficient, deep learning, I hope. And I think it is. I feel like I've got enough evidence now. Is that it? Oh, I clicked the link. Oh, that's kind of good actually. So student tech support has a lot of help available for you. So this is a link, that's what I clicked on. This image, I screenshot capture it from the website. So if you like, say, for example, your laptop dies or something, you can request a laptop or a hotspot if you don't have good internet at your house. And you might be able to get a laptop, or a hotspot to really get you going, because we want to make sure you do well. So if you need any help with that, the website is right here, and you just kind of click on, oh, I'm going to request a laptop or hotspot. Am I enrolled in a class? Yes. And then you just keep going through, blah, blah, blah. So if you need help, we're here to help. I think there's a limited number of laptops and things, but hopefully if you need one, there's one available. And we're going to meet in person in lab. Like I said, we're lucky enough to have some amazing instruments to use. So right now they're just letters, but you'll learn how to use NMR, IR, GCMS, HPLC, polarimeter, rotovap, and the most stolen equipment of all, balances. Does anybody have a guess at why balances, the thing that seems less technical, is stolen the most? So our NMR cost, we bought it like a while ago, but it was like $80,000. The IR is about 35. GCMS was like 40, but we got on a deal. It was like a $60,000 instrument. HPLC I got free. A company closed down and they were giving away stuff. But now the balances, they're actually like $1,000. But why would the cheapest piece of equipment here be stolen the most?
Maybe they're like the easiest to steal since they're smaller. That'd be my guess. I don't know.
Not quite. It's more because if you're the type of person who steals laboratory equipment, they're usually drug dealers. And so they want to like steal it to weigh out their pot or their cocaine or crystal meth.
I was gonna say that, but I wasn't sure.
Yeah. So it's like druggies that are stealing it. Because when I was at UC Davis as a grad student, we had 2 balances stolen. Because like you'll just leave your lab for a minute to go like get a cup of coffee and you forget to lock the door, and they'll just come through the hallway and try to steal it. So I remember once in my lab, I got the balance stolen and my case of CDs. I had like 30 CDs I really liked, just gone, bastards. But yeah, so you got to watch out. That's why the $1,000 instrument is locked down where the $90,000 instrument isn't, because yeah, they don't, when they're making crystal meth, they don't really care to take an NMR to make sure it's pure. For now, you need to use the Sierra app before coming into lab. And I did it myself. I think you get like a green pass if you just answer no to all the questions, like obvious questions like, oh, are you COVID positive? Then you shouldn't come to lab. And if you don't have access to the app, like, oh, I dropped my phone or something, or I don't have a phone, we have paper copies, but you want to like answer those questions before you drive to school. Because if you get an answer that doesn't allow you to come to school, you don't want to drive all the way to school and then find out, oh, I can't come into class. So do it at home. And then if you do get that, if you're using the app, they like call you, I think within like a half an hour. And a lot of times they're like, oh, wait, it was just your kid at school and they were like so far away from the person, is okay, you can go, this kind of thing. So yeah, Breaking Bad, Jesse. So for now on, you need to use the Sierra code. And then we're supposed to wear masks too. So I know that's going to be a challenge with a mask on. It makes your steam go up into the goggles. So we'll try to, when we have to wear goggles, we'll try to defog the goggles. I got some spray. And whenever you're getting too like fogged up, just walk out in the hallway. You could take your goggles off and get a little break. And don't have, I'll mention this in lab, but don't have food or drink in the lab, but have it in the hallway so you could go get a drink and a snack. And I'm actually done with the intro. Oh, cool. Thank you. That's nice to share the anti-fog spray. I think we got some too somewhere. Some anti-fog spray, which helps. Oh, and also if you're sweaty, I could just say this in lab too, but I know for me, if I'm wearing a sweater and it's warm in lab, my goggles fog up a lot. But if I take off my sweater now, I'm not as hot. My face doesn't generate as much heat, but everybody generates more heat. I think I generate more heat on my face than that. Some people don't generate much heat from their face, so whatever. Okay.
Springfield?
Yes.
Yes, quick question. The honors trials or contracts, or are those?
Yeah, I'll mention that later. Yeah, I will offer honors.
Okay.
Yep.
Thank
Yeah,
you.
yeah, good question. Yeah, I usually always have like 3 or 4 or so honor students each semester, and I'll tell you more about that. We have like 4 weeks or 5 weeks to get that submitted, so looking good. Okay, so since we got the bond online structure quiz on Wednesday, Thursday in lab, we should get started. You could actually, I think you do just fine if you just did, I'll show you. If you just did this on your own, well, I want you all should do this on your own, right? You'd be good for that quiz. You'd be ready to go. And so I could just say, okay, I'm not going to lecture today. You guys just go through this on your own. But this is really good. I spent so much time on these things. But I think it's good to get things multiple ways. So I'm not going to do that. I'm not going to say you just go through it. What I'll do is, besides having these Google slide animations, I'll give you lectures on the material. So I don't try to give you different examples. I think it's really nice to see it multiple ways, the material. So it helps you learn. And yeah, let's go for a little while, and then we'll take a break, and then we'll come back. Let's see how many people we got here. '21, nice, good turnout. I'm hoping to get that number higher each day too. I really think those of you who are here, that if you can come to every live lecture, it helps a lot, because if you have the video to watch later, it's easy to let those videos pile up. We're like, oh, I'll get to it later, and then you have 3 lectures to watch, and that's just a lot. Okay, so I have this Jamboard. Oh yeah, let me mention where you find that. So I have this Jamboard, and you can see it now, right? Because I'm sharing my screen, I believe. Am I? No, I'm not.
No, you stopped sharing your screen just like a second ago.
Thank you. Okay, now I'm sharing again, right?
Yes.
Yes.
Okay, so I'm sharing my screen. So I have the Jamboard for our today's lecture. Actually, let me close it, and I'll show you how you can find it. So if you go to our class, let's go from here. You go to our Canvas page. I think the best way is just go to OChem step by step. Top one there. And that will bring you here, which says, okay, I'm going to open this. I think it works better when I open it in another tab. It takes you out of the Canvas, but I think it's more effective. So here we are, week 1, Monday lecture outline. We already did that. That's why I just was clicking through it. Now here's the Monday's lecture Jamboard. So I can click on that link. And you guys should practice it. And I think the only time maybe you won't get in is if you don't have a Gmail account, which is free to get. Maybe everybody who's listening now, try to get on this, see if you can get on it. And if you can't, like, talk to me in lab, we'll get you set up on it. Okay, so I've got my Jamboard, and we're gonna do outcome 1, online structures. Yeah.
I just tried opening it and I can access it.
Cool, thanks. All right, so in bond line structures, it's a shorthand for drawing organic molecules. So organic molecules, oh no. My Apple Pencil is not connected for some reason. Let's see if I can get this going. Okay, it should work now. There we go. So organic molecule. So an organic molecule is carbon base, carbon skeleton. So that means it's like it's framework or carbon atoms connected, and then other atoms are connected off of that, like hydrogens mostly, and then oxygen, nitrogen. And so, for example, here's the molecule propane. Have you guys heard of propane before? You can use propane in your barbecue tank. So propane is a 3-carbon organic molecule. It's got 3 carbons connected together. So it's got that carbon framework, and then it's got hydrogens off of the carbons, just carbon and hydrogen in this guy. So it's got, each carbon has 4 bonds. And so you wind up with this molecule that has a formula, condensed formula C3H8. So if you have to draw out all these carbons and all these hydrogens all the time for every organic molecule, it would take a long time. It's kind of cumbersome, a lot of H's and C's. So our shorthand for it is we do bond line structures. And here's how it looks. Boop, boop. That's propane in the shorthand bond line structure. So that might sound strange, like what? What's going on there? And it's actually pretty simple. What you do, you just have to know a few rules to draw these. I said bond line strange. Bond line structure. All right, so the few rules. So a terminal end to a line is a carbon atom. And a bend is also a carbon atom. So whenever you have the end of a line, you say, oh, there's a carbon there. Whenever there's a bend, oh, there's a carbon there. And you add on enough hydrogens. You don't show the hydrogens in these structures, but you have to know that there's enough hydrogens there to give the molecule the correct formal charge. So usually it's 4. Let's just start with that definition, the simpler definition. So if I look at this carbon on the end here, this is definitely a carbon atom, and it has 1 bond to another carbon atom. So this carbon has the 1 bond there. So this guy needs 3 more bonds. So we would say, oh, there's 3 hydrogens there. How many, this bend here is a carbon atom. How many carbons are attached to this bended carbon here?
2.
2. Yeah, it's got a carbon there and there. So it's already got 2 carbons. It needs 4 bonds. How many more hydrogens does it need then?
2.
2. Just like that. That's why, that's where it came from there. And then this at the end is the same. So bond line structures are nice. You can draw the molecules up quickly. And as you get the hang of it, like right now, if you've never seen these, you're probably like, oh, what's okay, I got to remember a lot of things. But over time, your brain will just see this as a CH3. You'll see this as a CH2. It'll just become second nature. And that's why I have the glucoside animations, to get you there quickly, and also to make you just really strong at it, because then the rest of the year is ready to go. So let's just do more examples. Let me try propene. Propene is something we call an alkene. it has a double bond.
Oh, I'm sorry.
No worries. Huh?
Wow, it looks so dark.
Yeah.
I was just gonna hand you these.
All right, thank you. Oh, I forgot those. Thanks.
Yeah, no worries.
All right, so propane's got an alkene in it. It's an alkene. Oh wait, shoot. I started writing on slide 2, but I didn't change it for my video. Sorry. If you notice I do that, please let me know. Because I get confused now because I have my laptop screen and my iPad. Okay, so now let's draw that as a bond line structure. I'll call it shorthand again. Okay, so it's just this. So I have a terminal carbon here and there, and I have a bend there. So I have 3 carbons. So I'll call this carbon number 1, carbon number 2, carbon number 3. And this is carbon number 1, 2, and 3. There we go. There's a delay, sorry. And this numbering of carbons, that's going to really help you. I always joke around with students. I say like, oh, do you want to add like 5 to 10% on your exam score? They're like, yeah. I go, okay, just number the carbons. That's all you got to do. Because if you number them, you're much less likely to make a mistake. And a lot of times when you make a mistake and you leave off 1 carbon, it changes the problem to be really easy, which then how do I get partial credit for that new problem? Or it makes it super hard and then you're just stuck just because you didn't count your carbons. But it depends on what type of person you are. So if you're the type of person who's like, okay, I'm a rule follower, then I'm telling you, you should number your carbons. If you're the person who doesn't want to follow rules, usually you're like, nah, I don't read the instructions, I just move on. Then don't number your carbons because that's for nerds. Don't do it. Don't number your carbons, okay? Whatever you do, don't number them. You don't need to number them. And then, okay, let's get back to this guy. So this carbon number 1, how many bonds to other carbons does it have?
Two.
It's attached to carbon 2. Carbon number 1 is attached to 2, and it has 2 bonds. It has a sigma bond, a single bond, and a pi bond. We'll talk more about those. Sigma and pi. So it's got 2 bonds. So then how many more hydrogens does it need? Two, right? It's going to need 2, and that's what we see here. I know the answers are obvious because I already started that way, but I'm just trying to make it get you there. All right, and then carbon number 2, it has how many bonds?
Has 3 bonds to a carbon and then 1 hydrogen.
That's right, perfect, because it has 2 bonds to carbon 1 and just 1 to 3, so it needs 1 hydrogen. There it is. And then carbon 3, how many bonds does that one have?
One carbon bond and 3 hydrogen bonds.
There we go, perfect, yep. All right, let's do more examples. Now in this one, I'll do a little different. I'll give you a bond line structure and we'll go backwards. So, and also I encourage you to make up your own examples. I think as you get better at this, you get to the point where when I teach you something new, you'll be able to make up your own practice problems, and it really helps your learning skyrocket. I kind of stumbled across that because when I was in undergrad, I would study with my buddy Richard Alanese, and Richard and I, we'd study together, and if I got something, I understood something and he was struggling with it, I would try to make up practice problems for him, and the process of making up the problems made me understand it so much more, because if you can make the problem, you're thinking at a higher level. You're kind of thinking at the level of the instructor who writes the exams, because they have to make up problems for the exams, right? So it's really good to try to make up your own problems. So to kind of demonstrate that, I like to ask during lecture, help me make up a problem. So you can see that it's not that hard to make up a problem. So let's make up another one of these. I'm going to start with the bond line in this case, and then we're going to go to the expanded molecular formula. So the bond line that we're going to start. Okay, so the bond line we're going to start with, how many carbons do you want it to have? This is how you're going to help me make it up. Just give me a number between like 5 and 20.
6.
6. Okay. Do you want it to have any rings in it?
No.
Okay. Let's go 1, 2, 3, 4. Oh, I'm going to make this one tricky. This one's going to have kind of an exception in it. We'll have an exception. So this one, I'm going to go 1, 2, 3, 4. Wait. I guess I'll add another carbon. 5, 6. Okay, now this one's got an exception. Do you see why it's got an exception?
There are carbons where there isn't a bend or a terminal point.
Yeah, good. So these two, carbon 3 and 4, no bend, not a terminal atom, still a carbon. It's just an exception of the bond line structure shorthand because this is a triple bond here. It's called an alkyne. And the alkynes, they're linear like this, or straight across. We'll talk more about that too. But a lot of times people cheat it and they go like this. They'll draw the alkyne incorrectly like that. I don't like us to do that because the molecule doesn't exist like that. The molecule is straight like that. It's like how I originally have it. So you will see this in like, major journal publications. And I think it's okay to draw it that way if like you're a PhD chemist and you've been doing this for years and you're not like new with it, I still don't like it though. So I'm going to say don't draw those that way because it doesn't have that shape. Okay, so let's start going then. Help me out with this. This carbon, how many bonds to it? How many other carbons are attached to it? It's attached to carbon 2. Is it attached to carbon 3 directly? No. Is it attached to 4? No. 5? No. 6? No. So it has just one carbon it's attached to it. There's one carbon. So if it's got one carbon, how many hydrogens does it need?
3.
3 hydrogens. You got it. So the bond line structure will go red, I guess. CH3 to a C. And so that is carbon 1 and that is carbon 2. What about carbon 2? How many other carbons are attached to it? So we're looking at carbon 2 here. It's attached to carbon 1, right? Carbon 6 and carbon 3. It's got 3 carbons attached to it. So if it has 3 carbons attached to it, how many hydrogens will it have?
Just 1.
Yep. It just has 1 hydrogen attached to it. And this one is carbon 6, carbon 3. Do you see how the numbering helps? keep track of things. I'll tilt this a little bit so it kind of matches better. Okay, now let's do carbon 6. How many carbons are attached to carbon 6?
Just one.
Yeah, so how many hydrogens does it need?
Three.
3 again. Yep. 1, 2, 3. And then carbon 3, how many carbons are attached to it? How many bonds does it have? I mean,
4.
has 4 bonds. 4 bonds, 2 carbons. It has a triple bond to the right, that's 3 bonds, and then 1 to the left. So that could get a little bit confusing. So it's got 1 bond to carbon 2 and 3 bonds to carbon 4. So that's pretty ugly, sorry. So how many hydrogens should it have?
None.
None. Yeah, good. So carbon 3 will have just this triple bond to carbon 4. Get sloppy here. We'll finish this one and we'll take a break. Carbon 4. All right, and then now we just have carbon 5 and that one. How many carbons are attached to carbon 5? How many bonds does it have so far, I mean? It's got 1 bond so far, so it just needs how many hydrogens?
3 hydrogens.
There we go, 3 hydrogens. And that's the expanded formula. Okay, so you've probably seen things like this before in movies and things, like maybe like we were mentioning, someone mentioned Breaking Bad, where they draw the structure of molecules, and you might have seen like benzene. That's a common one you see. That's a bond line structure. And so now when you see these kind of on the whiteboard in the background of some movie at some college or whatever, now you know you know the secret language, and you'll get better and better at it. So why don't we do this? Let's take a 10-minute break, and then we'll come back and we'll do some more practice with this. Let's see. I'll set my alarm here. All right, 10-minute break. We'll come back around 12:03. Any questions before we go on break?
What day is the quiz due again?
I'm sorry, what?
What day will the quiz be due?
Oh, you'll do it in lab this Wednesday, Thursday. I'll show you the schedule. Yeah, here's our schedule. So today yeah, this is just the lab info. But today, those of you who have Monday lab today, we'll do the lab intro stuff, the icebreakers, and chapter 1. I'll continue with some chapter 1 stuff today because I really need you to get through this like bond line structure and basics, and then that will help you just for everything, like this whole spectroscopy introduction. I'm using bond line structures in that, so I need you to be decent at those already, and I need you to learn that right away. So, and then on Wednesday, Thursday, you'll start that spectroscopy introduction lab. Oh, and I'll tell you too, there's a pre-lab for that, and then bond line structure quiz. That's when it is. So do you have Monday or Wednesday? Do you have Monday, Wednesday lab, or Tuesday, Thursday lab?
I'm Tuesday, Thursday.
Okay, so Thursday you'll take this bond line structure quiz, which is at the end of, I should link it there. So the quiz is just this guy right here. So I'll give you like this bond line structure, and then you'll draw it like this and give the formula. and then I'll give you the bond, I'll give you the expanded, and then you draw the bond line, give the formula. So it's just practice that stuff. Exact same problems on the quiz. And to do, so yeah, I forgot to mention this. I should have mentioned this already. So the how to use our IR spectrometer. This is a big file I've made up. This is something I've worked on throughout the years. Well, not the IR one, it's the NMR one takes more time, but I've been working on stuff like this where I kept adding to it when I was teaching lab and lecture all on ground. And then when we went online, I had to make it all online. So that everything, the intro, the understanding of it, the questions, and then also the data I had to give you online. And I wanted you to feel like you were doing it. So I took a video of myself doing it in lab. So, but since I have that full online version of these things, then I wanted to make it back when we come back into lab. I set it up to where I still have that intro part of it, but then I took out the data given to you, so you'll get the data yourself. And so this one's, let me see how long this one. This is the first thing we'll do in lab, how to use our IR spectrometer. So this is only 15 pages, but within it, it's got video and animations to go through. And so I want you to get started on it before lab. So the pre-lab is basically to go through this file up to what I say. Question 1, it's not too much actually. Question 2. So yeah, you just go up to question 2. And the questions aren't challenging, they're pretty straightforward. Actually, that one's maybe a little bit challenging initially, but you'll get it. And then, yeah, you'll get through question 2. And then when you come into lab, you can keep going if you're into it. It's best to actually keep going. And then in lab, you would keep working through this, keep working through it. And then so the reason why, the way I was thinking, the way I'm going to do it is I will take some of you back to our IR spectrometer. This is our IR spectrometer. And I'll show you how to use it. I'll get you using it. And while I have a group of you back there with me working on this, the rest of the class, while they're waiting to get their turn to use it, they'll be going through this document and answering the questions, learning more about IR. And then we'll switch places. Yeah. Yeah, so I need to put that maybe in the lecture out.
Are we doing this today in the lab?
No, today is the lab intro, icebreakers, chapter 1.
Okay.
That pre-lab is due Wednesday, Thursday, and the quiz.
Okay. Thank you.
You're welcome. I should put that in here. The first part of OChem for 12A is it's a fair amount of me explaining how I want you to do things, and then it quickly gets into like, oh, that all makes sense, and now we're just learning. Okay, but it's worth the time to get you guys going like this, I think. Okay, so let me see. I want to add in. This is due Wednesday. Wow. Okay. I'll start my break over. We spent 6 minutes on not starting the break. Can't start. Okay, but before we do the break, do you have any other questions? Was I sharing the screen when I was doing all that? I think so, right? Yeah, good. Oh, I see some chat here. Let's see what's going on in the chat. Oh, that was a good question about what should we bring to lab first day. So if you have goggles, bring them, but you don't have to bring them that first day. Just because I think it's, well, actually, yeah, it doesn't matter if you bring them. And then if you can bring I think it'd be best if you brought a laptop if you have one to bring, or a tablet. Tablet might even be better than laptop, actually, if you have that, if you can write on it, or your cell phone. If you can't bring any of that, it's okay. We'll get you set up. But it's nice to have those so that if you have a computer, you can, as you're going through the introduction to IR, too many tabs open, how to use our IR. So as you're going through it, if you have your computer there or your phone or whatever, computer is just a nice bigger monitor than your phone, but you could do it without that. You can click on these links and now go through like this jam or this slideshow and learning about, we're going to memorize these certain peaks, you know. And then also I have a YouTube video where you'll watch for the first, like, I think you watched this one. It's a longer video.
My job is to make college
Commercial.
easier because students have a lot on their.
So you'll watch this and it'll be like, it's a 42-minute video, but you only watch till like the first 5 minutes, I think. And then it'll say, return to the document and answer questions. Yeah, so like right there, boom. So then, yeah. So then it brings you back here, you answer the question, blah, blah, blah. And then another Google slide animation, another question, and then you just keep going. And then here you see return to the 5-minute mark of the video, blah, 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 just keep going. I don't know why I'm saying blah, blah, blah so much, but. Okay, if you're feeling overwhelmed, like, wait, what do I do? Organic Chem step by step tells you what to do here. Due dates. I had questions about what to bring to lab the first day. And then I realized, yeah, I didn't really address those. There's so many things to say in the first week of OChem, stuff that doesn't even, it's not OChem, but you know, you got to set things up. And I always forget something, but one of the things I didn't really tell you what to bring to lab the first day. So if you come into lab today, you probably have most of this already, but today and tomorrow, can you bring, like as I was saying before, some sort of computer device that would help? But if it's not possible, it's okay, still come. But if you have a tablet with like a pen, or if you're comfortable writing with your finger on your tablet, that would be good too. We'll figure all that out. But a tablet, I think if you have a pen is maybe best, and then a laptop next best, and then a smartphone is good too. I just think when you're looking at the videos I have that I'll have you watch on a phone, it's a little bit smaller, but it's doable. And then also just paper, pen, and pencil for lab today. So for the first lab period. And then for the second lab period, the Wednesday, Thursday lab this week, there's a pre-lab. So you'll start working on this IR spectrometer. It's a document, it's an assignment that you're going to turn in, and it's how to use the IR spectrometer. And the way I'm setting up the pre-lab now is I'm setting it up so that the pre-lab isn't like separate from the assignment. It's basically, you're just starting the assignment. So as you're doing the pre-lab, you're getting done with the assignment too. So I kind of like that idea of that. I kind of slowly evolved away from, I used to, when I first started out, was like pre-lab, outline everything and do this and do that. And I felt like my pre-labs were just busy work. There wasn't a lot of learning going on. So now I like this a lot better. And you should feel better about like, oh, I'm doing the pre-lab, I'm getting the assignment done. So, okay. So I've added that to the end of my outline, updated it. And back to our Jamboard. So we left off with some bond line structure examples. I want to do some more. I want to do another one, and I'm going to add into this one atoms other than carbon and hydrogen. So let's go with, let's think of an interesting one. How about, oh, maybe we'll do that big one from the jam. Did I have that one? The jam. Here, I'm going to go about this. So I'm in Canvas. I'm going to go to step by step. That's a good way to go. I'm in there, and then I open it up, new tab. Online structures, Jamboard, and the quizzes at the end of it. This is, we'll do this one. This is a monster. Got this screen sharing thing in my way. Okay. So this is Dexum Methazone. It's a steroid used to treat skin problems, asthma, and COVID-19. Okay, so I'll put that on our Jamboard. Let's see if we can work out the, draw this with all the carbons drawn in. And you'll notice something, another kind of rule to this. I said earlier that when you have a bend in the bond line structure, that's a carbon atom. When you have a terminal to the line, it's a carbon atom. And you add enough hydrogens to get 4 bonds. We'll see there's some nuance to that later, but that's most of the time. So like this terminal carbon needs 3 hydrogens, terminal carbon needs 2. I mean, bend carbon here it has 2, so it needs 2 hydrogens, 3 hydrogens. All right, and then we did see the exception where like the alkyne, it's not a bend or terminal, but you could tell that there definitely needs to be a carbon between 3 and 4 because they got a triple bond. And now when another thing is for the atoms that are not carbon, like this oxygen, you do draw hydrogens on carbon atoms. So you see here, we do draw that oxygen. Oxygen's on a carbon and it has a hydrogen, so we draw it. And we do it here too, right? This is an oxygen. And if there's, usually it's an oxygen or a nitrogen, that's what you see. Yeah, so we got that. And, oh, you know what? This has wedges and dashes, huh? I haven't defined that yet. Well, we can still do it without worrying about it. So I'll define it really quick. So a wedge means the bond comes out of the page. Or I'll say screen since we're online here. It's a 3D thing. It's not flat in the screen. It's coming out at you. Okay, so that means coming out at you. The dashed bond goes away from you. It's pointing into the screen. Okay. So, but they're still just bonds, and it still applies the same rule. Like, oh, this is a terminal bond here. That wedge, that's terminal line. It's a wedge, I know, but it's considered like the line. And so that's 1 carbon with 3 hydrogens. And this dashed one over here, that's going to be 1 carbon on the end with 3 hydrogens. Okay, so let's draw that out. This is definitely one that'll be good to number. This number, let's start over here. 1, 2, 3, 4, 5, 6. Let's go 7, 8, 9, 10. This is a monster one. 11, 12, 13, 14, 15, 16, 17, 18. I'll just number those main ones, the rings and that ketone and alcohol at the end. Well, later we'll define that this is a ketone, this is an alcohol. You'll get the hang of it. Also, just real quick to note, this is a steroid, like I was telling you, and I can tell it's a steroid right away, and you will be able to too, because it has a 6-atom ring, a 6-atom ring, and a 6-atom ring, kind of in this like 6-6-6 form, and then a 5. So when you see 6-6-6-5, you're like, oh, that's a steroid. Oh, I wonder if it's like an anabolic steroid or what's the deal there? My favorite steroid is Flonase. So I get the spring allergies and I put that Flonase in there. That steroid works great for me. All right, so here we go. Enough talking about it. Let's do it. So carbon number 1, boom, it's got the 2 bonds to oxygen, a bond to carbon 2, and a bond to carbon 6. Let me number those, make sure we got it all right here. This is 1, 2, 6. So does carbon 1 need any hydrogens? Or does it already have 4 bonds? If I can see.
It already has 4 bonds.
Yeah, good. Already has 4 bonds. So it needs 0 hydrogens. It's done. And if you'd like, when I'm asking questions, I like to ask a lot of questions as we go through the lecture, make it more of they call it the Socratic method. Like I'm Socrates and you're my pupils. So I like to do that. So if you want, besides answering verbally, you can type it in the chat. I got that up now, the Zoom chat. Okay, so now let's go to carbon 2. It's got a double bond to carbon 3. And that's it. So how many bonds does it have besides, how many bonds does it have shown so far? Actually, not 2 bonds. It has 2 to carbon 3, but it also still has 1 to carbon 1. So it has 3 total bonds currently. So 3 bonds, how many hydrogens are left over? Or how many hydrogens does it need? Just the 1. There you go, good. And now for carbon 6, it's got a double bond of 5. Yep, and then how many total bonds for carbon 6? Yep, it has 3 bonds. It has 2 to 5 and 1 to 1. So how many hydrogens does it need? Just 1. There we go. Okay, and then 5 and 3 connect at 4. And 4 has a bond, the bonds to 3 and 5. And it also has a bond up here too. Which number did I get that? 10. And a wedge to another carbon there, because that's a terminal line. So this is carbon 4. This is carbon 10. There's a wedge, which I didn't really assign a number to because it's just kind of off of 4. So how many bonds does carbon 4 have to it? Got 4. Does it need any hydrogens? Needs none. Yep. Now let's do this methyl, since sorry, I gave it away if you know what a methyl is. Let's do this carbon up here on the wedge. So how many bonds does it have currently? Has 1 bond to the carbon 4. Good. So how many hydrogens does it need? Three. There we go. Got 4 bonds to that one. Okay, we'll build off of 5. Why not? We'll go over here to 7. Yeah. 7 has a bond to carbon 8 and 5. That's it. So how many hydrogens does 7 need? So it's got 2 bonds currently. 1, 2. Needs 2 hydrogens to get to 4. There we go. And then carbon 10, oh, it has a bond up to carbon 11, and then one down to 9. And then it's got this dashed one to the fluorine. And the fluorine is not a hydrogen, so we draw that in. Fluorine's got some lone pairs. We'll talk more about them as well. You see how the numbering of the carbons is really helping us keeping this. There's a lot of things going on here, but these numbers are helping out, huh? Keeping track of everything. Now, carbon 10, how many bonds does it have? Yep, carbon 10 has 4 bonds. Need any hydrogens? Nope, it's got no need for hydrogens. And then 9 and 8 are connected. Let's finish off 8. How many bonds does 8 have? 1, 2. So how many hydrogens does 8 need? 2 is right. And if you're following along with this is excellent. This means you're going to do well on the quiz, because this is way more challenging than the quiz examples. You just have to practice the quiz a couple times, and it's the exact same quiz. Okay, so we got 9, and then 9 comes out to 14 here. And yes?
Are you okay with us taking screenshots?
I'm sorry, what?
Are you okay
Oh,
with?
am I okay with? Yeah. And also though, definitely feel free to take screenshots. I wouldn't know really, but that's nice of you to ask. And then also this Jamboard that I'm writing on, it's going to be linked and shared like right here. You'll be able to look at it later.
All right, thank you.
But you might have wanted to do a screenshot because you want to see the progression, right? Not just the final answer. Okay, so now number 9 actually is breaking the rule. I didn't realize this till now. It's showing this wedged hydrogen, huh? Why is that breaking the rule? I'll make it red so we see. So we're showing an H on a carbon. Something we're not supposed to do, right? We're supposed to leave all the hydrogens off. I guess I should put the star right there, huh? The reason why that's being shown, it's being shown to let the reader know about the stereochemistry of that carbon. So I just threw out the word stereochem like nothing. You're like, what is he talking about? So stereochem is something we're going to go into in great detail in chapter 5, and you'll get really good at it. But for now, stereochem is describing how a molecule can have a certain 3-dimensional arrangement to it. That's important. And when we get to stereochem, you'll find having this hydrogen wedge versus dash could be huge. If it were not wedged and it were dashed, it might not work for COVID-19 patients, sort of thing. Okay, so we got that one in there. So does number 9 need any more carbons or hydrogens? It's got 1, 2, 3 bonds, 4 bonds. It's done. Okay, so 9 went out to 14, huh? There's 14. And then 11's right there. Let me finish off 11. 11's got a wedged OH, alcohol, and a bond to 12. I'm gonna run out of room here, huh? Okay, so did 11 have? No, 11, yeah, it does. It has the wedged OH, so it's stereochem. The thing we're going to go into detail later is defined for it. But does it need any hydrogens? Eleven has 1, 2, 3 bonds. So how many hydrogens does it need? Just 1. Good job. I'm liking the chat on the, and it's wedged back. We'll talk more about how you would know that's wedged back later. wrong spot. I'm breaking the octet rule for number 4. It's 11 that needs that wedge dash back hydrogen. And I'll tell you why it's dashed shortly. All right, so 11's done, and then 12. Let's see if I can make this guy shrink down and get it to fit better. Yeah. Okay, 12, what else does it have? It has 13. And 13 goes to 14 too, yes. Let's make that hexagon there. So what do I need to do to 12? What should I add? Or should I add anything to 12? 2 hydrogens it is. Yep, that gives it 4 bonds. 1, 2, done. 13's attached to 16. And 16 goes over here to then that goes to 15. I don't know why I didn't give that a number, huh? 13, 14, this is 15. I just left off a number. That was, oops. Does anybody like this stuff? I remember when I first learned about bond line structures, like, oh, that's kind of cool. Yeah, it's kind of like a puzzle. As you go through OChem 2, you're going to find a lot of it's like a puzzle. It's a lot of drawing, and it's got a lot of general chem, basics to it, but it's not so like mathematical, where sometimes in general chem, the math, you can get so caught up in the math that you forget you're even doing chemistry, where this is different. Okay, so that one forgot to number. But it's okay. It's as long as I draw the right molecule, right? Okay, so what about 15? Let's finish 15 off. What do we need on 15? Do we need any hydrogens on 15? Yes, 2 hydrogens. Good job. And then the non-labeled one has a dashed. So that non-labeled forgot to number. Forgot the ER of number. Forgot to number. What should I? What does it need? Does it need anything? Need any hydrogens?
Doesn't 14 need one as well?
Actually, let me double check 14. 14. Did I add it and take? Oh wait. 14. Did I skip 14? I did. Oh, I forgot. 14 needs ones as well. Thank you. Good job. Yeah, and it's shown above, huh? It's already dashed because it's like showing you the stereochem at 14. Okay, yeah, my H is ugly on 14. Thank you for the fixing that. Okay, now, do I need any hydrogens though on that, then one I didn't number? Okay, so I see, yes, 1 hydrogen. Yeah, and it winds up, it's wedged. We'll go, you probably wouldn't know it's wedged now, but you need to know now that there's 1 hydrogen. Later, we'll go into why it's wedged. Okay, and then this carbon that's coming off the end there, that terminal one, how many hydrogens does it need? Good job, you're getting it. 3. We call that a methyl when a carbon has, it's 1 other carbon and then 3, or it doesn't even have to be a carbon, just a carbon with 3 hydrogens is a methyl. Okay, and then 13, does 13, oh, 13 has a wedged on it, wedged out group. Okay, so does 13 need any more hydrogens? Let's count it. So for carbon 13 right here, it has 1 bond to 14, 1 to 16, 1 to 12. That's 3. And oh, and it has another bond up here. This is a carbon up there, that wedge. So no hydrogens needed for 13. It's called, oh, you know how I said, we'll talk more about this later. I said this is a methyl when it has 3 hydrogens. This is a quaternary carbon when it has no hydrogens, quaternary. All right, and then the wedged out guy, how many hydrogens does it need? Right here, this one. Trace. Trace 3 gives it 4 bonds. And then 16, almost done. 16's got a wedged out ketone, which we'll define later, and a dashed alcohol. That's that number, that ketone, carbonyl, carbon 17. Okay, so does 16 need any hydrogens? Zero hydrogens, already got 4 bonds. 17 here, it's got a double bond to an oxygen. This is called a carbonyl when you got that carbon oxygen double bond. And another bond to 18. So does carbon 17 need any hydrogens? Put this. Carbon 17 needs no hydrogens, it's got 4 already. Carbon 18 has an alcohol, yep, OH there. And does it need any hydrogens? It's got 2 bonds, it's got 1 bond to another, to carbon 17, 1 bond to, to an oxygen. It needs 2 hydrogens. Yep. Hydrogen, hydrogen. There we go. And we're done. We've decoded this, what do they call it? Decahexa something or other. Is the bond is here. So this decahecamex in hospitalized patients with COVID-19. So it's kind of sad when you look into these studies where they'll give some of the patients the drug and some not to see whether it works. And the people who get it, if it really works good, you feel bad for the ones who didn't get it and died. You're like, oh shoot. And then so when will we learn why there's wedges and dashes? Shortly. Actually, I can give you a little preview. So let me see what time we got. Right now we're at 12:50. So I'll pause today's lecture on material covered, but if we go to the where is it going? Animations? Yeah. If you go here, I got lots of these animations and things I've made up for you. And oh, can you guys do this for me? I had my daughter Michaela. So my daughter Michaela, she's 17. She graduated from Rockland High, and she's going to be going to UC Santa Barbara with her best friend Dana, who just graduated from Rockland too. Their roommates. I think they found out today what their dorm room is going to be building they're in and stuff. But so Michaela was born my fall semester of 2003, my first year at Sierra College, and now she's moving off to college. And she did this bond line structure one, the one that you're going to do for the quiz on Wednesday, Thursday. And she said it took her about 25 minutes. And I would like to have data on how long all of these take. I think I forgot to ask. I think I'm going to add to them like, oh, here, I'll put it here. Where should I put it here? I'll just do a new text block. So we're up with that. Make a smaller text maybe. Let's go add animation. That come in. Give them a little bit of that. See how the sausage is made back here. Okay, yeah, so it'd be cool to have data on these. So it's probably nice for you guys to say like, oh, this only takes about 25 minutes. But maybe my daughter was clicking through it fast because she's like, come on, Dad, I haven't even done the general chem yet in college. So, but yeah, it'd be cool to have that here. Some are quicker than others. And I went through this. Oh, yeah. Someone was asking me in the chat. I forgot why I was talking about this. I think they were asking me, how do we know what's to deal with these wedges and dashes? And that's the very second animation. So after you finish the first bond line structures, it's bond line structures in 3D. That's the one I was showing you the stereogram. And we go into all has to do with just wanting to be chill, like the Chichi Bobbin. Here it is. There they are. The wedges and dashes. So it starts off here. Like, oh, not there. There you go. Yeah. So like a wedge is coming out of dash back. And then when you get to tetrahedron, yeah, this is the slide. That'll answer your question maybe. So if you have like this carbocation and it's rotated, and then you add in a fourth thing, all the atoms want to be as far apart as possible. And to be as far apart as possible, they want to take on what the shape is called tetrahedron. This is wedged out at you, and that's dashed back. That's what a tetrahedron is. And the lines are in the plane of page. So that was a real quick answer, but you'll build up to understanding that later.